Hello, and welcome to this new edition of NAPA Echlin Education. The word tune-up is a term that we really don't hear that much anymore. There are some vehicles on the road today that do a general tune-up maintenance from time to time, but for the most part, vehicles are requiring more preventative maintenance versus a tune-up. And oftentimes, we'll find that those tune-ups or preventative maintenance needs to be done in different climates, such as during the summer and during the winter. So today, we're going to talk about some tips and tricks on tune-ups to get cars more winter ready for this new season of cold weather that's going to be coming in. My name's Corey Mayfield. I'm glad you're here, and let's get right into it. Now, before we get started, we want to make sure that we remind everybody about the contest that is actually ending today after this session for an all-expense-paid trip down here to Irving, Texas at our training center and vehicle test facility. Now, this trip is going to include your airfare, 2 nights hotel, all your meals, local transportation to get you back and forth, and more importantly, and most importantly, 2 days of hands-on class training, where 50% of that is going to be in the classroom and 50% is going to actually be in the shop doing activities around the knowledge that you've learned. Now, we're going to have 10 winners total, and again, we're going to be drawing those after today's session. And all that you need to do to get entered for that drawing, if you look at the bottom of your screen, you should see a little tab that says Q&A or question and answer. Go ahead and open up that Q&A panel and just go ahead and type in all the information you see here. Your first name, last name, shop name, your city and state of the shop, and a valid email address, because we want to make sure we get everybody in that wants a chance at winning that trip down here for that classroom training. So while everybody's in the Q&A box getting their information put in there so you can make sure you're entered for that contest drawing, let's talk about the term tune-up. Now, 30, 40 years ago, it was one of the most common terms we used in shops. It was very simple. A car came in, maybe it needed an oil change, air filter, and fuel filter, and that was a great time for us to suggest maybe spark plug wires, spark plugs, even older vehicles, maybe a distributor cap, rotor button, things like that. Unfortunately, we don't see a lot of those vehicles on the road anymore. There's still plenty of them, but the amount of cars coming through the shops today versus those kind of cars is night and day. So really, a tune-up today is all really more about preventative maintenance for some of the harshest conditions that the vehicles can be, subjected to, especially in summertime and what we have coming up next, which is wintertime. And so we want to talk about some of the most common things that you might want to look for, or you might want to suggest to your customer when they bring the vehicle in the shop to kind of get them ready for those seasonal changes. Now, I know we've all seen this one, and it's a pretty common thing, but this is maybe the easiest tune-up recommendation you can give to a customer. We've all seen that vehicle come through that has had a leak for who knows how long, right? And there's no coolant in the vehicle. They've just been topping it off with water all summer just to make sure the vehicle didn't run hot, which it probably still did anyway, but the reality is it's full of water now, and now we're going to start seeing below 32 degrees many nights of the year, and that's just going to freeze everything up. So in some cases, a tune-up for a vehicle in winter, or a winter tune-up for that vehicle, could be as simple as, hey, maybe let's fix that leak and let's get you topped off with coolant the right way. And so with that said, sticking with the theme of fluids, this is definitely a tune-up or a preventative maintenance item that we should be talking to our customers about. So again, if it goes back to the vehicle that had the leak and has just been running water for who knows how long, that's a preventative maintenance or tune-up item. But the same thing holds true on things like brake fluid, power steering fluid, anywhere that we can look that may need topped off, flushed, or again, it may have a leak in the system and it needs to be fixed so that those items don't cause issues with the vehicle operating normally during the winter season. So we understand fluids, but how about tires? Have we ever thought about tires as a tune-up item or a preventative maintenance item? I mean, obviously we check tire treads and things like that when a vehicle comes in, and we want to suggest tires when they need them. But at the end of the day, usually tires, we drive them until they wear down, we get new tires, and that's the end of the story. And there hasn't been a whole lot of change in tires over the last 40, 50 years. I mean, obviously we've seen differences in quality. It's gone up. Rubber compounds have changed. Tread types have changed. All that's very true. But when we think about tires as a tune-up item, let's not talk about the tire itself. Let's talk about the technology inside the tire. So we all know about TPMS sensors. And the reason I point these out, and it's a really good idea to do this, is when you have a vehicle in the shop, especially in the wintertime, it's good to take a TPMS tool around the vehicle and check all 4 tires. And the reason for doing that is pretty simple. We've all had these for a good 20 years or so. They have batteries inside that definitely die at some point, usually between 7 and 10 years, but some can go sooner and some can go later. But the reason I point that out is this: we've had these out for so long now that most people understand that, I get home at 7, 8 o'clock tonight, car's gonna sit for 10 hours, it's a cold night, the next morning I start the vehicle up and start going down the road, the light comes on, oh, that's right, because it's cold outside, the air's more dense, so I'm just gonna drive for a little while, it's gonna heat the tire up, no big deal, the light will go off. Well, if the light never goes off, chances are they're not gonna bring it in just because that light's on. Car's driving just fine, but they may not actually know if there is a nail in the tire with a slow leak, or they may not know that there's a bad sensor or a dead sensor inside the tire. And the biggest problem with that is if we have a dead sensor or a inoperable sensor, we should be getting a flashing light as well. Most of our customers out there don't know the difference between a steady light and a flashing light, so oftentimes it'll get ignored. But if we take that one next step when the vehicle's in the shop to spend that 1 minute, minute and a half to go around the vehicle and check the TPMS sensors, we may have an opportunity to take care of a customer on one bad sensor, maybe it's got one with a dead battery, something like that, and make sure that they don't have that light steady or flashing through the winter season. That way when they do warm those tires up, that light should go off like it's supposed to, and they've got that peace of mind. So now we can think about both fluids and tires, or TPMS sensors, as common items that we could be looking at to help our customers get their car ready for the winter season. But I think a lot of times when we think about tune-ups, we think about the ignition system, but we don't really think about it or equate it to a time of the year. It's just the ignition system. But in the wintertime, the ignition system can fall susceptible to increased moisture in components, difficult starting conditions in the cold, and even greater opportunity for ignition leakage. And the ignition system is something we want to replace as a system, not just components. And so we're going to talk about that a little bit. When we think about a winter tune-up, what can we do to help our customers prevent drivability issues when it's cold outside? So whether it's fluids, whether it's tires, TPMS sensors, things like that, there's a lot of things we can do with tune-up, but now we're going to get more into the drivability side of things. What can we do tune-up wise to help the drivability of the vehicle and keep our customers driving no matter how cold it is outside? And so when we think about ignition, obviously we're going to think about coils. And over the years, coil designs have changed. Distributor systems used a ferrite core coil, which had better heat dissipation than the early field designs. And then the next development was distributorless, or say DIS ignition, in which the coil fired 2 spark plugs each time it discharged. And then finally, the coil moved over to the coil on plug, the COP type design. And again, these are all designs and types of coils we're going to see coming through the shop still today, even on some of the older vehicles that are coming through the shops. Now, when we think about distributor ignition systems, or DI systems in SAE terminology, these were used well into the 90s. And there are still some vehicles on the road today with distributor ignition systems. Now, the early versions have the pickups for trigger and sync housed in the distributor. Now, these signals are usually inputs to the PCM, which controls the ignition module. In later vehicles, though, the pickups are located on the engine itself. Now, with distributor ignition coil operation, essentially the coil creates the high voltage needed to fire the spark plug from the 12-volt electrical system of the vehicle. Essentially, it's a transformer with the thicker high current windings connected to the battery and the thin low current windings connected to the spark plug through a cable or a spring. And so when the transistor switches on here at point A, the current's going to flow through the primary and create a magnetic field. And then here at B, when the transistor switches off, the magnetic field collapses across the secondary windings and creates a huge spike in voltage, potential of several thousand volts, and we see that here at point C. That voltage is going to be enough to ionize the spark plug gap, and a spark is created with hopefully enough to ignite the compressed air and fuel in the cylinder. And then once that all takes place, the voltage is no longer adequate to ionize the plug gap. The voltage is absorbed by the primary winding. And with a distributor system, the distributor is actually only used to operate the camshaft position sensor and to distribute spark in the correct sequence. The distributor has no influence on base timing, and the distributor is not adjustable on V6 engines, but its position relative to the crankshaft can be adjusted on V8 engines since the terminals are close together in the cap. Now here's a quick power tip for you. If the distributor on a V8 engine is not properly adjusted, the rotor gap will increase and possibly cause a crossfire. So you can use a scan tool to check the cam retard offset PID with the engine off, idle a little over 1,000 RPMs, and it should be close to zero. And then of course, as the technology moved away from the distributor type ignition systems to the coil on plug system we see today, the spark plug cables have changed as well, where in some sets you would get a short wire between the coil on a particular cylinder or plug, all the way up to even just a boot and spring, depending on which system you were working on. Either way, these are very susceptible to moisture intrusion, corrosion, and all kinds of different things that cause connectivity issues between the boot and the plug, or the boot and the coil itself. And so when it comes to winter tune-up thoughts, these are things we can be looking at to try to maintain these components rather than let them allow that moisture to intrude and cause issues with connectivity. And then we moved away from distributor altogether and we went to DIS ignition systems. Now in a distributorless ignition system, the crank sensor is going to provide an input signal to the powertrain control module and in some cases or the ignition control module with information such as engine RPM and where top dead center is for number one cylinder. Now the PCM or ignition module will then determine the correct firing order and command the ignition coil to fire. Now the PCM will typically determine and command the amount of timing advanced required. And in this scenario, the ignition coil will be fed constant B+ and consist of two windings, primary and secondary. Now the ignition module will command a coil on by providing a ground signal to the coil. Now this will charge the primary side of the coil, which acts as a voltage amplifier. When the module commands the coil off by removing the ground, the magnetic field built up in the windings of the primary coil will collapse rapidly, causing high voltage, which will discharge through the secondary winding and out the coil tower, through the spark plug wire, and eventually jumping the gap of the spark plug to ignite the air-fuel mixture in the cylinder to create combustion. And a quick power tip on these types of systems, companion cylinders share coils. If there are misfire DTCs on the same coil, suspect both plug wires. And as we go through the ignition types, we also have to factor in some of the other components related to the ignition that are just as susceptible to common failures and wear when it comes to either extreme heat or extreme cold. And crankshaft and camshaft sensors are right there in that mix. And the crankshaft sensors set the ignition timing, and they supply the RPM signal and determine engine speed. So that's pretty important. And the camshaft sensor is going to determine which cylinder is firing to establish injector synchronization and coil firing sequence in a DIS system. And so it's critical when we're thinking about winter tune-up items or things that we can suggest or look at for our customers during the winter season or even summer season for that matter, but the winter season for sure, that we look at and we consider crankshaft and camshaft sensors for a couple of quick reasons. One, the pigtail. The pigtail is very susceptible to damage from the road, moisture intrusion, rodents chewing on the wire. That can cause a lot of issues with timing and with communication to the PCM. But also the rubber O-ring that sits between the sensor and the engine itself. If this starts to degrade, it can actually cause the sensor to back out a little or move forward a little in some cases. We don't want that because this is a specific length and a specific width for a very specific reason. It's designed for that vehicle's system. And if this is off by just a little bit, it can cause a lot of issues with timing. And one of the things that we know winter does is it destroys seals and it destroys O-rings. So if we already have an issue with misfires or drivability, this is something we want to look at to help our customers through the winter season and make sure that we don't have degradation on that ring or with the pigtail itself. And now moving on from cam and crank sensors, the ignition control module or ignition module is also a pretty common item that fails on these types of systems, and wintertime definitely takes its toll on them. And the ignition module tends to be a high failure component due to the following issues. Opens in the secondary winding can cause the arcing to ground from the coil towers down to the ignition module, causing high voltage to travel through the module, damaging electronic components in the ignition module. And then opens in the secondary can also cause extended dwell times and overheat electronic components. Many of the ignition modules ground through the base of the module, so it's extremely important to thoroughly clean the surface of the bracket the module mounts against, and all the mounting screws are used and properly tightened. Use heat transfer grease where you should as well on these ignition control modules. And so now we move on to coil-on plug systems, which is a system that has gained popularity because of its universal application, controlled precision, and increased capabilities in the coil-on plug ignition system. Now, much like the DIS or distributor-less ignition system, the coil-on plug system is going to rely on a crankshaft position sensor as an input to the PCM for engine RPM and cylinder identification. So again, we're going back to that crankshaft sensor, still very important regardless of either of those systems that you have. Now, each cylinder has an ignition coil mounted directly on top of the spark plug, and these coils will typically have a power and ground feed along with a trigger input from the PCM. The signal will tell the coil how long to stay on and when to turn off and discharge, sending the spark out directly to the spark plug. Now, on these systems, the secondary consists of the secondary side of the coil, the boot or insulator between the coil and plug, and the spark plug itself. And the absence of plug wires decreases the risk of secondary leakage. However, there is now more demand placed on the coil-on plug system, and of course, cost savings are involved. So there are still plenty of failures with this type of system. And so just like we were talking about with the crank and cam sensors, when we talked about that rubber O-ring and the pigtail, the same thing's going to hold true on coil-on plug systems. We still have rubber boots, we still have metal springs, and we still have terminals that are all susceptible to that corrosion and moisture intrusion. So it's really easy on some vehicles. I understand on a lot of vehicles it is hard to get to all of the coils and all of the plugs. But if it's one of those easier vehicles where we can just kind of pull a bolt and take it out and take a look, it might be something to look at to check the quality of the boot. Is it still in good condition? Quality of the spring, and also the connectivity of the pigtail to the coil-on plug. These are all things that we can look at and suggest to our customers to make sure they don't have any issues with misfires from their coils on a coil-on plug boot system, especially during the wintertime. And then if we're talking about coil near plug ignition system, the ignition system consists of a separate ignition coil connected to each spark plug by a short secondary wire. And the driver modules within each coil assembly are commanded on and off by the PCM. Now, the PCM primarily uses engine speed and position information from the crankshaft and camshaft sensors to control the sequence, the dwell, and the timing of the spark. So again, with like all the other systems, regardless of which one it is, we have multiple components that are in play that we have to make sure are in top running condition to withstand those either extreme heat temperatures in the summer or extreme cold temperatures in the winter. And here's a good example of what that might look like, where we have each ignition coil with ignition 1 feed and a ground, and the PCM is going to supply a low reference and an ignition control circuit. Now, each ignition coil contains a solid state driver module, and the PCM commands the ignition coil circuit on and off to allow current flow through the primary coil windings for the appropriate time or dwell. Now, the coils are current limited to prevent overloading if the ignition coil current is held too high for too long, and the spark plugs are connected to their respective coils by that short secondary wire we were talking about. Now, we can't really talk about coil-on plug without talking about Ford coil-on plug systems. And Ford coils are notorious for causing misfires. In fact, they may cause network communication problems by spiking KVs back into the PCM. Now, if KV flashover has occurred at the spark plug, the plug and wire or coil for the coil-on plug must be replaced at the same time. A faulty coil-on plug can cause miscellaneous flickering warning lights such as theft, ABS, and more. Spark plugs now for these systems, even when seemingly identical to the eye, have different constructions and heat ranges, so be sure to install the correct ones. And some engines employ a multi-strike ignition strategy, so the spark plug is fired 2 or more times for each ignition event. And multi-strike ignition makes for more complete fuel burning processes at idle. It is usually disabled though at 1600 RPMs or greater. On 2007 and newer Ford vehicles, they have the spark duration PIDs that can be checked. Now here's some more ignition tips, kind of secondary ignition tips, things to think about. Plug wires. Spark plug wires are the weakest link in any ignition system, including DIS. Failure of the wires can cause the secondary current to flow to ground before reaching the spark plug electrodes, causing a cylinder misfire. So a power tip here is a maintenance tune-up or comebacks are not uncommon. No matter how careful you are when you replace the spark plugs, the old hard boot does not seal against a new spark plug. Moisture gets in, spark leaks out, and the car comes back with a miss in a very short amount of time. If the customer just refuses replacing the spark plug wires at say 100,000 miles, at least try and put some dielectric grease in the boot. And that's actually something I would recommend regardless of what type of system it is. If it requires spark plug wires, I would always recommend dielectric grease in the boot, on the plug, as well as on the terminal end of the connector. It's always a good idea. It's a little bit of insurance just to help keep moisture out and maybe prolong the life of those plug wires, maybe even the spark plug itself. And now with coil-on plug systems, the ignition systems may have eliminated the plug wires, but they have introduced a new failure area, the boot. The boot is placed in a very hot area, right on top of the cylinder head, and undergoes extreme thermal cycling. So eventually moisture and or oil is going to seep in between the boot and the plug, and arcing can occur. Once the arcing has happened, a carbon track begins to form along the side of the spark plug, and the misfire becomes more and more severe. And so just like with spark plug wires, we still want to use dielectric grease whenever we plug our coil-on plug onto the spark plug. But again, if we have a perfectly good ignition coil, the coil-on plug, there's nothing wrong with trying to recommend replacing just the boot and possibly even the spring, which could very well prolong the life of the coil-on plug as well as the spark plug. And again, for a winter tune-up, that's going to help keep moisture out of the system as well. And so we say all that to say this: no matter how careful you are when you replace certain ignition components like spark plugs, spark plug boots, or spark plug wires, anything that makes contact that's going to receive a high voltage, comebacks oftentimes are related to a connectivity issue, meaning that there is something that is in the way of the spark plug wire and the spark plug, or the coil-on plug and the spark plug, or that wire going to the distributor or going over to the coil pack itself. And one of the things we can do in just about every case, and we've talked about it a couple times already, is using that silicone, that dielectric compound grease in between those connections to make absolutely sure that regardless of whether it's hot outside or freezing cold, we're going to have good connectivity in all of our ignition related components. And so when we do have a vehicle in and we're talking about winterizing, doing a tune-up, or maybe we're just doing a routine maintenance and we come across something, is this something we need to diagnose, or is this something that immediately needs service? Always going to recommend that we follow OE recommendations and replace secondary components as a system, not just one piece at a time. And that goes with just about anything. But when it comes to ignition, if we're going to do the wires, we may as well go ahead and do the plugs, and vice versa. If we have a system with 4 coil-on plugs, we all know that if one failed, the other 3 are going to shortly be right behind it. So we might as well replace all 4 of those if we can get the customer to commit to that, as well as the plugs at the same time. With the ignition system, everything ages at the same time, over the same amount of mileage, and as one component fails, the others are shortly there behind it. We all know that. So it's always good to keep that in mind when we're talking about a diagnosis, a service, or considering a winter tune-up. Always try to put the system back together as one unit and with the most new components as possible so that we get longevity out of the components that we replace. And so with all that said, before we go, there's a couple of other quick tips I'd like to give you on winterizing or doing a winter tune-up for your customers' vehicles. Now, see a bunch of AC components here. We've got a heater core, we've got the AC compressor. Why would that be out when we talk about winterizing or doing a winter tune-up? Well, the reality is we know there's a lot of cars running around through the summer that maybe have a busted AC system. They didn't mess with it because maybe it wasn't affordable at the time, but now winter's here. Well, when we come out at 6 o'clock in the morning, 7 o'clock in the morning, and that windshield's frozen completely over, we need to defrost it. That's going to be pretty hard to do if we have an inoperative AC system. We still need that dry air to get that defroster to work strong and properly. So if we have a customer in the bay that we know has an AC issue or has complained about an AC issue, this is a really good time to talk about the compressor, talk about the heater core, talk about the other components related to the AC system, because they may not be aware that their defroster is not going to work very well if these components are not working properly. And the last one I'll leave you with is, just like those TPMS sensors and those batteries that can possibly die, one of the things we absolutely have to check during the winter are car batteries. That actual battery that's sending all that voltage to all those ignition components that we just talked about. So we have AC systems to think about, we have fluids to think about, TPMS to think about, ignition to think about, batteries to think about. There's a whole host of things that we can do to help get our customers' cars more winter ready and keep our bays turning at the same time. And so with all that said, I'd like to thank you for being here, and I'd also like to welcome you to our NAPAechlin.com website, where not only you can look up parts, but you can get a ton of information on different types of components, how they work, digital resources, interactive buyer's guides. There's a whole host of information on NAPAechlin.com. It's free for you to use. There's no need for a username or password. You just go to the website, and all the information that's available to you is just a click away. Also, don't forget about our NAPA Echlin YouTube channel. Now, this is a 30-minute class that incorporates a little bit of information from several 3 to 4 hour classes. And we also have on YouTube hundreds of videos with all kinds of information, diagnostic tips, installation tips, and a closer look at some of the components that we have in our box. We'd welcome you to go to that site and just check out some of the videos, and honestly, get with your representative in the field, and if they have tips or ideas for videos that you'd like to see, we'll take that information and be glad to move forward with it and try to get a video out there for you that might be helpful. And folks, don't forget about the November and December Jumpstart promotion for Echlin's Winter Tune-Up. Any variation of ignition coils, caps, and rotors, or wire sets and ignition modules, when you buy $500 worth, you're going to get that $50 Visa gift card. So make sure you take advantage of that. And so from all of us here, we want to thank you for joining today, being in attendance, and we hope to see you next year when we do several more of these types of classes on different types of systems and things that you might want some more information about. Thanks again. Have a great rest of your day. We'll see you next time.